everyone. Thank you for watching our presentation today. We're sharing our analytical findings of our sustainable product concept, Solar Stop, a solar-powered outdoor charging and study space designed for tough students. Our goal in this project is to take the initial idea that we proposed in assignment 1 and refine it using real data from tough students. We wanted to understand not only whether students would use something like this, but which design features matter most and where these benches should actually be placed on campus. So let's start with a quick recap of our initial idea. So in assignment 1, we introduced Solar Stop. This was our concept for solar powered outdoor tables and benches equipped with overhead solar panels that generate clean energy. These benches would include USB and wireless charging ports, comfortable seating, shade protection, and built-in tabletop for studying. According to our initial research, each unit could generate over 600 kilowatts of clean energy per year, which translates into reducing roughly 550 pounds of CO2 annually. Along with the environmental benefits, the concept also solves a real student problem, the lack of convenient outdoor charging options. We also looked at the cost, of course, of implementation. Each bench was estimated to be around 350,000 yen, or about $2,800. With a payback period of just over 5 years. And based on sunlight and foot traffic, we originally recommended placing these benches near libraries, dining areas, and the walkway between academic buildings. So that was our starting point, but we knew we needed more than just a concept. We needed actual data from tough students to validate or improve the design.
And then to guide our analytics, we developed the following research question, which would be, are students satisfied with the charging options already available on campus? And how likely are they to use sustainable outdoor charging stations? This question helped us stay focused on what mattered most: demand, satisfaction, and willingness to adopt a new sustainable solution. We also wanted to learn which features students value the most, so things like shade, comfort, charging speed, or location, so we could refine our design based on actual student priorities rather than assumptions. And then this led us into our survey. So to collect meaningful data, we asked tough students to a set of targeted questions about their habits, preferences, and needs. We first asked what devices they bring to campus and how often they need to charge. This helps us understand overall charging demand. We also asked where they currently charge their devices, whether that's classrooms, the library, lounges, or outdoor spaces, which reveals whether students already use or avoid outdoor areas for studying. Next, we focused on campus routines by asking where they typically spend time between classes and which locations would be most convenient for charging. We also measured satisfaction with existing charging options, so the likelihood of using solar powered bench and interest in sustainable energy. And then finally, we asked students to rank different features: seating comfort, weather protection, lighting, and fast charging, and to share their preferences for free versus paid charging. Together, these questions gave us a very clear picture of what students want and what they're missing. From the survey results, a few themes stood out immediately. First, students bring a lot of devices to campus. Every respondent brings a smartphone, and more than 80% bring a laptop. But even though 2/3 of students need to charge at least once during a typical week, outdoor charging options are almost non-existent. 78% said that there are not enough outdoor charging stations. When students do charge, they mostly do it indoors, especially in the library, which was selected by over half of the respondents. But interestingly, When asked where they prefer to spend time between classes, 41% said outdoor spaces. This tells us that students want to be outdoors, but they're forced indoors to charge their devices. We also found strong support for sustainability. 74% said that they would prefer using renewable energy sources, and nearly 80% said they'd likely or be extremely likely to use a solar powered charging bench. And finally, cost matters. Over 80% of students said they want charging to be completely free, though they'd accept a small fee if needed for maintenance. These insights confirmed that Solar Stop solves a real problem and gave us direction for the design features that matter most.
Our interpretation and insights. Are students satisfied with current charging options? Ultimately, SPSS results confirm that students are not satisfied with the current charging options at Tufts. 85% of responses were either dissatisfied or neutral on the availability of charging options. This indicates that there is room for improved outdoor charging infrastructure.
Here we highlight the fact that students aren't just unhappy with current energy options. They're actively interested in more sustainable ones. Our survey shows that nearly 75% of students prefer renewable energy options. This means Solar Stop doesn't just solve a need, but it also aligns with students' values.
Perfect. The likelihood of using Solar Stop. Students are likely to use Solar Stop as 77.7% of the survey voted extremely and somewhat likely. These variables indicate that there is a strong user demand for renewable outdoor charging stations. What predicts usage? The regression model summary. R equals 0.283, indicating that our original prediction of Solar Stop being integrated into campus successfully aligns closely with the findings in the survey. The p-value being less than 0.001 indicates that the model is highly statistically significant. Data demonstrates to us that user sustainability's attitudes are the strongest driver of behavior to encourage the use of Solar Stop, with individuals being motivated by clean energy and positive environmental impact. Ultimately, the ideal bench setup answered by our research question is to include free charging and to have the bench be multi-purpose.
So connecting the feedback from the Tufts students, there were two main critical points made, which were that the main profit model was unclear and indoor charging spaces already meet most of students' needs, and how we used this feedback and built upon it. For the profit model, being unclear is after utilizing our survey and regression analysis, we concluded that 77% of students are likely to use Solar Stop charging stations, proving that there's a strong user demand, which indicates a positive return on investment. And for indoor spaces already meeting most needs, we found that our survey proves that 78% of students agree that there is not enough outdoor charging options, as well as only 7% currently charge their devices outside, showing a massive gap in available infrastructure. And lastly, 41% of students prefer to spend time in outdoor spaces, showing that students value being outside and having multiple options for device charging in short distances. And then to conclude, talking with the Tufts students taught us how cultural perspectives shape how a project is valued, emphasizing practicality, efficiency, and shared use of space. Their feedback helps challenge us and prove through data gathering that Solar Stop as a whole can be a beneficial project for helping out students and the environment. Thank you.